right, we are continuing in OLI Mod 9. We're going to take a look at how we can get the 5-number summary calculated for us in StatCrunch and then start using it to help us with some other characteristics of our data set. So we're going to return to that cereal brands data set that we've been looking at so far. From my home page here in StatCrunch, click on datasets, and I'm going to search for cereal. Click on the data set we need, and there we go. We've got our data loaded into StatCrunch. All right, so to get this 5-number summary, it actually comes from exactly the same place that our measures of center did. So we're going to click on Stat, pick Summary Stats, and then Columns. Let's see. This question says we're going to focus on sodium, so I'm going to click on the sodium column. Now, down here for the statistics, you can click on these values in any order, but I really like to have them come out in the order of my 5-number summary. So that's what I'm going to demonstrate here. So I need to scroll down for that. The first thing I need is my minimum value. And remember, for your following values, I'm going to either control click or command click on a Mac. So Q1, the next thing I need is the median. I need to scroll back down to get Q3 and then back up to get the maximum. So I've got my 5 numbers that I need for my 5-number summary coming out in order. Click compute, and there they are. So let me go ahead and transfer those over to my Word document here. So let's see, our 5-number summary is 0, 130, 180, 210, and 320. Okay, let's see, that 3 wasn't too good. Whoosh. All right. Sodium amounts vary by how much? Well, they're not specifying any certain subset of the range, so this is just our full range. Will give us the full amount that those sodium amounts vary. So we're going to take our maximum piece of data, 320, subtract our minimum, which is 0. So we are going to end up with 320, and we should attach some units there. Sodium is in milligrams. Okay, the middle half of sodium amounts vary by how much? Well, now, since we're focusing on the middle half, and we're asked for the amount of that variation, that is going to be our inner quartile range. So we're going to take Q3, which is 210, subtract Q1, which is 130, and get our inner quartile range of 80 milligrams. Okay. What percent of cereals have a sodium amount less than 130? Well, 130 is here. It is Q1, so we know that the amount of data to the left is 25%. What percent of cereals have a sodium amount less than 210? Well, 210 is our 3rd quartile of Q3. So we know there is 25% of our data to get back to the median of 80, another 25% of our data to get back to Q1, and then the bottom 25% of our data to get back to the min. So that is a total of 75% of our data. All right, The next thing we're going to do is use our inner quartile range to identify potential outliers. Now, we've talked about outliers before, just in a general way of them falling outside of the pattern and the scope of our data. But right now we're going to give something a little more specific, and that is that outliers lie more than 1.5 interquartile ranges outside the inner quartile range. To figure out where the outliers are, we will first need to calculate some dividing points for these outliers, which are called fences or boundaries or limits. I'm going to go ahead and call them fences, but it does vary from text to text, from researcher to researcher. Okay, so let's think about how we're going to calculate the upper fence. All right, so let's think about our data layout here. We've got a min, Q1, Q3, and our maximum. And we know that right in here from Q1 to Q3, that is our inner quartile range. So to come up with these fences, we need to go outside of this inner quartile range an amount of 1.5 times the inner quartile range. We need to do that on the left. We also need to do that on the right. Okay, so if I'm looking for the upper fence, I'm looking for the dividing point here on the right-hand side. So we're going to start at the upper edge of the inner quartile range, which is Q3, and we're going to add to it 1.5 times our interquartile range. So specifically in this case, we are taking 210, adding to it 1.5 times 80. Those are the values for the inner quartile range that we calculated above. That was 80, and then Q3 was 210. So this gives us a value of 330. Well, we know from the 5-number summary that our maximum piece of data was 320. And this dividing line goes all the way out to 330. So certainly no data lies past 330 because we know it stops at 320. So by this, we know that there are no high outliers. No data is past this dividing point of 330. We know that because our maximum is 320. All right, let's go ahead and calculate our lower fence. So this time we're starting on the lower end of the inner quartile range. We're going to start at Q1. We're going to subtract 1.5 times the inner quartile range. So Q1 is 130. We're subtracting 1.5 times 80, and we will come up with 10. So this time our minimum value is 0, and yet our dividing line for outliers is at 10. So we do know that we have low outliers because our minimum value is less than our lower fence. So in our next video, we will take a look at where we're going to go from here.